Alright, so let's talk parent functions and transformations. Parent functions are the most basic a function can possibly be. Parent functions that you guys should be familiar with at this point in your life should be that y equals x squared, y equals x cubed, y equals the square root of x, y over x squared. The absolute value of x, one that you guys might not have seen, might be this greatest integer function. I know I didn't get to talk about it too much with you guys, so I'm just going to assume that not a whole lot of people have seen it. So I'm going to jump over to Google real quick to show you an image, just because Desmos didn't like it the other day. The greatest integer function basically looks like a piecewise function on crack over and over and over again. All it does is round the number down to the nearest integer, so it always rounds itself down to the nearest whole number instead of up, which is interesting. So even if you have 1.999999999, that's still going to round down. So that's kind of different. It's not common among any other thing else, but that's where it's at. Jumping back to the notes. Again, this was just an exponential. This is also just an exponential. Logarithms, which are just the inverses of exponentials. And then sine, cosine, and tangent, you guys all learned last year. Again, I would know at least 5 points on each of these graphs. If you don't, I would kind of go back and look through those. Calculus does expect you to know those. Alright, and the reason why they expect you to know those, because if you don't know the parent function, it's pretty hard to graph transformations dealing with those parent functions. So if we're just giving some function of x, and we're saying, hey, what does a, b, and c do to the original function of our new function, which is going to be a times the function of b times the quantity of x plus c plus d on the outside. Alright, so looking back on last year's notes, I'm going to try to zoom in. Alright, it's zoomed. A is just going to go ahead and be that vertical stretch. It makes sense. If a is larger than 1, it is going to be a vertical stretch. But if a is less than 1, then it is going to be a vertical shrink. And again, vertical is up and down. And D is also going to affect our vertical. It's going to make our y's either go up or go down. So that is my shift. So if D is positive, it's going to shift up. If D is negative, it's going to shift down. You'll know because the sign will be positive for shifting up, and it'll be negative for shifting down out in front. So, outside of our function affects our y values. Alright, so going inside, just meaning the inside of f, I've got b and c. So, inside always is weird because it does the opposite of what we think that it would initially. So instead of it affecting our vertical, it's actually going to affect our horizontal. So, b is going to be my horizontal. Shrink or stretch. So I say shrink because if b is a whole number larger than 1, it is actually going to be a shrink. Let me clarify that. Let me backtrack a second. If b is larger than 1, it is going to be a shrink. Alright, that says it a little bit better, so. And then if b is less than 1, then it is going to be a horizontal stretch. Alright, and then finally, C, which I'm running out of room, so I'm going to make that a different color, just so we can kind of see. We're going to see C. Alright, anyway, so C is on the inside, it's being added. Well, adding on the outside shifted me up and down, so adding on the inside is going to shift me left and right. So again, it's still on the inside. It's going to be the opposite of what we think it is, because most of the time we want to say, hey, plus is going right. No, no, no. Plus on the inside actually shifts you left. So if it is positive, you are shifting left, versus if it's negative on the inside of your function, then it is going to be going right. Alright, so summarizing that up in a little chart like we had last year. Oops, I need to zoom out a little bit. So if I've got the inside, it's going to be, my x's are going to be opposite. And then if it's outside, then my y's are going to stay the same. Alright, so if I've got f of x plus c, what that's going to do is it's actually going to shift me left c. Versus if I have f of x minus c, then it's going to shift me right c. Alright, so I would have something like x minus c comma y, and then I'd have x plus c comma y, which is kind of nice. And then if I have plus or minus on the outside, what it's going to do is it's actually going to shift me up d. And then I'm going to be shifting down if d is negative. Alright, and then here's where it gets weird and back in my bottom left corner. So I've got f of bx. So what I'm going to have to do is I'm actually going to have to multiply by that reciprocal when I'm looking at x. So I'm going to have it's going to be technically a horizontal shrink. If b is greater than 1. So my point would end up being 1 over b, comma, y. 1 over bx, comma, y. And then if I have a negative, what it's actually going to do, if it's on the inside, it's going to reflect over that y-axis. So I would have reflect over, and why that is if I have a little graphy graph here, and I've got a point just sitting over here, and I am trying to go ahead and change my x value, what's going to happen? Well, my x values are going along this particular line, right? So if I switch it, then it actually, my x value goes from here to here, and it's actually going to switch over to being a negative x value, which in turn reflects it over that y-axis. Alright, and then last things last, I have a times f of x. This one's pretty nice to remember. It's a vertical stretch. If a is larger than 1, alright, if a is in between 0 and 1, it's a vertical shrink. And then if I have a negative on the outside, it's going to be a reflection as well. And it's going to be over the x-axis this time. Because again, the outside affects my y values. If I have a y value down here, and I need to change that y value to being the opposite, well, if this is my y-axis, and it has to be the opposite of being negative, it's now going to be positive. If it's still y distance from 0, 0, or the origin. So if I switch that over, it's actually reflecting over that x-axis. Alright, let's go on to the next piece.